Hey, and welcome to Average Acceleration, Instantaneous Acceleration, brought to you by The Essential 55, an award-winning educator's rules for discovering the successful student in every child, by Ron Clark. What a phenomenal book! Thanks, Ron Clark. So, for this lesson, we're going to talk about average acceleration, and then again, I'll just talk about instantaneous acceleration. Basically, instantaneous acceleration is all about the change in your velocity at that specific moment. Usually we care more about average acceleration than anything else. So here's how we're going to do this problem. Pretty simple. Find the average acceleration, so that's what I'm looking for, of an object that starts from rest and goes up to a velocity of 48 meters per second in 22.8 seconds. Okay, well, first off, what is the equation? Average acceleration, written like that, again, the average, equals the change in velocity, so I'm looking at the change in velocity, divided by the total change in time. Well, for the change in velocity, so I gotta look at what velocity I started with. If I really wrote all this out, which I don't think you have to do, to be honest with you, you should know this, but basically it's written like this. The change in velocity is VF, your final velocity, minus your V naught, your initial velocity, divided by your final time minus your initial time, T naught. Okay, but again, you don't really have to show this part, just the numbers are important. So your last velocity is 48, and you started at 0. You started from rest, so it's 48 minus 0. So again, you finished your final velocity at 48 meters per second, and you started at 0. So it's 48 minus 0, divided by your final time was 22.8, and you started your time at 0. So 48, basically it's 48 divided by 22.8. Okay, so let's just type that in the calculator. 48 divided by 22.8. Give you a whole bunch of numbers, but I'll just write some of those down. Equals 2.10526. 526. Okay, now again, because this is division, fewest number of sig figs. 48 has 2 sig figs. 22.8 has 3 sig figs. So I want 2 sig figs. So I go 1, 2. Look at the number next to the 1. It's a 0, so I'll keep this a 1. And because these numbers are after the decimal, don't make them zeros, because then they'll all be sig figs. So my answer would just be 2.1, and then the units for acceleration are meters per second squared. Now, if you read the textbook and all that stuff, you know acceleration is a vector, which means it has to have a direction. Notice though, I didn't write north, south, east, west, left, right, up, down, positive y, positive x, negative x. Sometimes the fact that a number is positive is a direction. Sometimes it's assumed that if it's a positive number, it's along the positive x, or it's going to the right. It's just assumed that. And because acceleration is positive, that means you're going faster at that rate. If the acceleration is negative, it can mean you're slowing down at that rate, but not always. Because sometimes a negative acceleration can mean you're speeding up just in the opposite direction, which, again, we'll talk more about that when we get to graphing motion. That'll make a little bit more sense. But in this case, I'm speeding up 2.1 meters per second squared. And that's all there is for average acceleration. Instantaneous acceleration, again, is just talking about the acceleration at that particular moment. But acceleration, very simple. Just remember the equation. the change in velocity divided by the total change in time. And you're done. That's it.